In this section, you will learn how heat transferred by convection 對流. Let's look at the example. When an electric kettle 電水煲 is switched on, the water inside will be heated up quickly. Can you explain how heat is transferred from the heating coil to the water? In a liquid, the particles are moving around. When the kettle is switched on, the heating coil becomes hot. While the water particles near the heater are heated up, the volume of the water expands. That means this section of volume will increases. Okay? That means expands, 膨脹. And the water at the bottom has lower density, 低嘅密度, than that at the top. Therefore, the hot water particle at the bottom will rises, 上升, and transfer energy to the top. The energy will be together transfer upward. Meanwhile, the water at the top has higher density, and the cold water particles will sink. As a result, a convection current 對流 convection current forms, and the above process is repeated processing until the water is heated up to the same temperature. This way of heat transfer, the hot water rises and the cold water sinks, and the heating process is continuing. This way of heat transfer we call convection 對流. We have an experiment. Two boring tubes A and B are filled with water. In tube A, ice cubes are put at the bottom of the tube, and in tube B, ice cubes are put at the top of the tube. The boring tubes are heated at different positions by the Bunsen flame as shown. In tube A, the tube is heated at the positions above the tube, and in tube B, the tube is heated at the bottom. Explain why the ice cube in tube A doesn't melt, but that in tube B will melt very soon. The reason is that in tube A, the water is heated near the mouth of the tube. Therefore, we have a convection current flows in the water at the tube at the top only. That means there is only a convection current near the top. Hot water rises and cold water sinks. Okay. However, in this case, low heat can be transferred to the bottom. Therefore, the ice cubes remains not melted, because the temperature of water at the positions near the ice cube, the temperature is low. In tube B, the water is heated at the bottom of the tube. In this case, the convection current flows inside the whole tube. From the bottom rises to the top and then back to the bottom. The hot water rises and the cold water sinks, and eventually energy is brought by the hot water particle to the top. Therefore, the hot water rises to the top, and the energy carried by the hot water helps to melt the ice completely. Now, let's see an experiment to demonstrate the convection of air. The procedures are: first, we have a large box divided into two compartments, A and B, by a cardboard. Secondly, a lighted candle is put in the compartment A. Next, a joystick 拜神用嘅香 is put above the opening of compartment B. The last step is to light up the joystick. 點着呢一支香。Can you explain what will be observed? Look at the remark. Since air particles are invisible, 肉眼睇唔到嘅, so we light up the joystick to produce large smoke particles for us to see, which indicate how air flows inside the box. Let's start explaining what will be observed. The candle flame will heat up the air in compartment A. When being heated up, the air inside compartment A has smaller density and rises through the opening. Meanwhile, the air in compartment B is cooler than that in A. Therefore, the air in B has greater density and then sink. As a result, a convection current 對流 flows from B to A through the opening at the bottom of the box. At the same time, the smoke particles from the joystick will flow from B to A. Along the direction of convection current and comes out from the opening at A. Throughout the process, we have a convection current in the diagram. The hot air rises and the cold air sinks. Examples of convection. Number one, why air conditioners are installed at a high position while electric radiators in 暖爐 are put on the ground when they are in use. Air conditioners emit cold air. Since cold air has higher density, therefore the cold air will sink. So air conditioners are installed at a higher position. However, electric radiator will heat up the surrounding air, and these air particles will become very hot, becoming hot air. Since hot air has smaller density, therefore the hot air particle will rise. As a result, electric radiator are installed on the ground level. Question number 2. The diagram shows the place near a coastal region, 沿岸地帶. You are asked to draw the convection air current in the daytime and in the nighttime respectively, and please explain your answer. In the daytime, the air above the ground is hotter than the air above the sea. Since hotter air has lower density, the hot air will rise and the cool air above the sea will sink. An air current will flow from the sea to the ground and produce what we call a sea breeze, 海風. However, in the nighttime, the air above the ground is cooler than that above the sea. Since cooler air has higher density, the cool air will sink and the hot air above the sea will rise. An air current will flow from the ground to the sea, and this will produce what we call a land breeze.